Both private VLANs and protected ports give you the ability to control the flow of traffic between interfaces that are part of the same VLAN or subnet. Now, with protected ports, you can only control that traffic flow on an individual switch, but with private VLANs, you can control the traffic flow on an individual switch or between multiple switches. But regardless of whether you're using protected ports or private VLANs, you're going to run into issues related to misconfigurations. And the misconfigurations are going to result in clients being allowed to communicate with each other when they shouldn't be, or clients not being able to communicate with each other when they should be. So it's very important that you have the ability to review the configurations of protected ports and private VLANs so you can pinpoint where you made your mistakes and fix them. Catalyst 2960 series switches don't have the ability to support private VLANs. However, they do support the protected port feature. Now, we have to always remember that the protected port feature is going to prevent traffic from flowing between switch ports that are configured as protected ports. However, it still allows traffic to flow between a protected port switch port and another switch port that is not configured as a protected port. So you might run into the issue where clients are able to communicate with each other when they shouldn't be because you misconfigured the protected port feature. Or you have clients that are not able to communicate because you misconfigured the protected port feature as well. So either or can become an issue with that protected port feature. In our topology, we have PC1 and PC2 that are connected both to ASW1. Right now, they are able to communicate with each other when they shouldn't be. So let's access PC1. On PC1, let's ping the IP address of PC2. We have connectivity. We shouldn't have connectivity because the protected port feature is supposed to be enabled on Fast Ethernet 0/1 and Fast Ethernet 0/2. So if we analyze ASW1, it's commands of show interface Fast Ethernet 0/1 switch port, and we go all the way down to the bottom, we'll see that the protected port feature has been enabled on Fast Ethernet 0/1. However, is it enabled on Fast Ethernet 0/2? And the answer to that is no, it's not. That's why PC1 and PC2 are still able to communicate. PC1 has protected port feature enabled. PC2's interface does not. As a result, traffic can still flow back and forth. The only way that traffic's going to be prevented from flowing back and forth is if they're both configured as protected ports. So configure terminal interface Fast Ethernet 0/2, switch port protected, not switch port security, switch port protected. There's the command we want to utilize in order to enable Fast Ethernet 0/2 with the protected port feature. So let's verify that that is true now. And we'll see from the output of show interface Fast Ethernet 0/2 switch port that the protected port feature has now been enabled on Fast Ethernet 0/2. So Fast Ethernet 0/1 and 2 are both protected ports. As a result, we should no longer have communication between PC1 and PC2. Success. We cannot reach PC2 anymore. However, can we still reach our default gateway? Let's type that in. Ping 10.1.1.1. Yes, we can. Can we still ping PC3, which is connected to ASW2, even though it's in the same VLAN? Yes, PC3 is still reachable. What about the internet? 192.168 or 192.0.2.1? Yes, we can as well. So that protected port feature is designed to control the flow of traffic between two switch ports on the exact same switch as we saw in the example. But it's only going to do so if both switch ports are configured with the switch port protected command.